let me give a little bit brief bio for them. And Dr. George is from Google. He has more than 20 years of experience. We kind of had a quick intro and then before. He is leading the module Google systems.
Okay.
And also, previous to joining Google, he was a CTO of
Can you hear me?
Voxer, as well as he co-founded MindMeld. He got a PhD from Wisconsin Medicine and holds 5 patents. Leandro Silvia is production engineer from Meta Systems, Meta, and he is focusing on hardware health automation and building scalable system tools. And Mohan Kumar is an Intel fellow. He has more than 25 years of experience in server systems and architectures. He has over 200 plus patents and publications. Kundala Devendra God is a senior director at Microsoft. Currently, he leads system engineering in Azure. Prior to joining Microsoft, he worked in Intel for more than 17 years. He holds a master's degree in EEE and executive MBA from University of Washington. And he co-led the OSF in OCP for 2 years. Dr. Chanko Choi leads Samsung SSD research and new features initiatives. And we have a kind of, you can see a lot of good experience here. That's probably the thinking is we will have about 5 minutes. We will have open questions to them. And I will open up for the Q&A for all of you. The good thing is we want to make sure that whatever the questions you have, you're able to get the experts able to answer the questions. Maybe to start with, given in the OCP or running the cloud, all of you might have interacted with, you have an in-hand experience as well as you interacted with the cloud vendors. Based on that, what do you think, what is the challenges in onboarding, getting the system up and ready for using in cloud? Is there anything that we have to do in the standard side to make it better? Maybe I will start with Leandro and just all of you can answer, or if anyone of you want to jump in, go ahead.
Can give a stab. So I think it goes along with the question that a colleague had earlier, which is, as a hyperscaler, we have a heterogeneous environment, like with diverse range of hardware from different vendors. So building the tooling to make sure that all the servers behave and they interoperate the way we expect, like we can confidently identify that they're running healthy, and we can repair them as fast as possible whenever a problem arises. I think that's one of the biggest challenges, that having more standards and like bridging this gap would be beneficial like for everyone in the industry.
Okay, could I add one more thing? So I think it would be related to Leandra's answers. Actually, I'm from Samsung. Actually, we are SSD vendors. When you work with many cloud service vendors, cloud service vendors' requirement is a little bit different. For example, telemetry one. Each company has their own requirement and they want to have some specific information. There is some information is common, but many information is exclude each other. So as a vendor, we need to service all the, we need to service a superset of the requirement. That is already challenges. And also, when I do some research with some telemetry data inside the company, sometimes we cannot get a clear ideas how those information is used in the industry and the field. So if we could get more information then we could provide also we could suggest some other telemetry data set, because it's based on some use cases and requirement, uh, such as like a NAND thing. So we are kind of an expert. But as you know, if we know your use cases and requirement, then we could work together and develop a better telemetry items together.
So I'm from Google. I think at hyperscaler scale, we want extremely like low touch systems. So we do not have like human resources to go debug things. So we are highly like automated. So the telemetry we want like rich set of telemetry that we can automatically diagnose issues, right? So we have like fully automated systems that can basically like take down a drive, detect a failure, do all the appropriate steps like, in a fully automated manner, and the telemetry that we want has to support it. Similar to what Changchua mentioned, is that we ask vendors to provide the same thing. But that's a problematic thing because it's not an open standard. It makes it hard for us to like integrate like a new product or a new hardware into our cloud data center, right? But if you standardize it, it will benefit like vendors as well, and it'll also benefit us because we'll have multiple vendors who support it. So it's a lot easier for us. And the industry as a whole would also benefit because some of the things that we actually did to make it low touch would basically reduce the management cost for others as well.
Yeah, so I'm from Intel. I would agree with Samsung on the problem. Uh, so we work with a lot of cloud service providers, and of course with all our customers, and they have varying requirements. And our job is to be able to service the superset of the requirements that they all have. But the challenge is not really standardization. There's lots of standards in manageability area that exist. The challenge is how well that standard is adopted and used, because there is so much variance in even a given standard. It becomes very, very hard for us to produce the same data. So some of the discussions earlier on data models, that resonates with me, because to the last degree, the data model has to be the same across all these cloud service providers, or you're still back into the superset of providing everybody in the world. So that's really the challenge I think is for the CSM work group eventually to solve. Is to get that one model that everyone agrees on, so then we can produce that one model as the silicon vendor.
Go ahead.
Yeah, I'm from Microsoft. So from Microsoft point of view, and one of the CSPs in the industry, the way I see the problem is like if you go back to the history of the cloud models, it is there for a reason, right? So it is for scale, it's for performance and security. You can leverage the service all over anywhere in the world. So these are some use cases in terms of the cloud use models. But the area where once we design and deliver into the data centers, managing, that's where the whole ROI is built into it, right? So the promise, the SLAs, all those things we promise to the end customers in terms of the SLAs and reliability and availability, if we are not consistent across that manageability space, remotely managing and providing that services to the end users is where the open standards needs to be innovated. And what resonates to me with this group is the hardware is really accelerating at a much faster pace than somebody can provide the service model on top of that layer, is where the standardization comes into picture. Even the simple device proliferation and the underlying hardware from different silicon vendors and the security blast radius, all those things, the end user promise we have to, the only way to do it is to innovate in the space of standardizing the interfaces, how we can maintain them in the fleet, right? So there are multiple aspects of it. Even the simple case, like a use case like making the firmware fresh all the time, so that any anomalies we have taken care in real time, while giving the same SLAs to the end customers, is where this really resonates to me in terms of this work group. And there's a lot more to be done, but it's just this in the right direction we are heading. That's what my view is.
Thank you. Parnas, you're on, awake still at night. Do you want to add anything to more? Thank you.
I don't know if I'm heard in the room.
Yeah, we can able to hear you.
Yeah, we can.
Is the sound coming? Oh, okay, okay. So yeah, I would augment the fact that now the space is very fragmented in the sense that from the hyperscaler view, some of us have their own solution of monitoring stuff, and then from a vendor point of view, there is proprietary or extensions to the standards that they want to have as a sample. So I think that most of the vendors don't have the scale of the hyperscalers to test their devices on. So a challenge in the industry is to bridge this gap and allow the vendors to get their hands on the data they should be looking at from their own devices, and at the same time service the hyperscalers with the high expertise of the vendors on a massive scale of data, this massive amount of data that can be generated inside the hyperscalers and inside the large data centers.
Good, thank you. I think people can line up if you have any questions. I will start with another question, otherwise I have a lot more questions to add. Yeah, go ahead.
So with sustainability becoming a big part, one of the areas that people are talking about is densification, liquid cooling, et cetera. And this is one area that certainly could use a lot of standardization or standardized approaches. What are your thoughts about liquid cooling and the rate of adoption? And do you also agree that it's going to help towards sustainability, et cetera?
Yeah, I'll take a stab at it. So I think that's a great question. So that's exactly what this work group, earlier we talked about. The underlying technologies are innovating at a faster pace, right? So if you're not ready for really having those interfaces standardized, the telemetry and then maintaining that fleet for this new hardware models is a gap currently, right? So that's exactly what this group is trying to focus on. As an example, in the liquid immersion or any other technologies, all we cannot do any physical hardware replacements or anything. It's all built in, and otherwise the ROI will not be there, right? So in those use models, the only way we can, the saving grace is to have that remote manageability capability without touching anything in the data center. And if you standardize all the devices, how they behave, how they pump the data back into the upper layers, is where the standardization comes into picture. Yeah, we have a lot of protocols, lot of things today, but there's no a consolidation of all the devices talking the same language, right? So as soon as you change the underlying technology, then we have to start reinventing or extending stuff. So there is a need for extensibility of what existing standards, not to reinvent it, but to make it very standard for across the industry, right?
So, by the way, that's a great question. We actively work on this area because as the power increases, you can keep cooling it with air, but the problem is the fan power. The power increases basically cubically with the fan speed. So at some point you have multiple fans. Right? You have the fan on the CPU, you have the fan in the system, you have the fan in the air handling unit, you have a fan at the data hall, and the number of times you are essentially repeating this process to move the hot air to cold air for the efficiency that you're getting, gets to be a place where you have to look at alternate technologies. The moment you go to alternate technology, which you're talking about immersion, but there are other alternatives too, right? So they have the radar heat exchanger, they have cold plates and so on. But let's talk with your example, which is immersion. Once you go to immersion, you basically cut out all the middlemen, right? Essentially, your cooling is at one place, right? And then all you got to do is to exchange that heat with some external entity, and you're done. So a lot of the intervening stages get bypassed. So you get efficiencies. So that's why folks are leaning towards that space these days, in addition to other advantages. To Devender's point, it also introduces a lot more surface, right? You're looking at, it used to be racks, now it'll be tanks. It used to be different set of sensors. You used to have thermal sensors, but the same thermal sensors no longer work when you're in an immersion medium. And the kind of telemetry that you need to have in place is completely different. The lifecycle management is completely different, because nobody in their right mind is going to stick their hand into a liquid and pull this out, right? I mean, even if it is safe. Robotics is going to become very critical in the future. How are you going to tell the robot, which one to remove, which one to not remove? Where's that precision going to come from? There's a lot of surface that's, we're just scratching the surface on all those things in this forum. And there's a lot of opportunities there as the world transitions slowly from the current solution to something like immersion.
My take on it is that there's going to be heterogeneity, right? There's a case for liquid cooling for certain very high performance things. There's going to be a case for air cooling for rest of it. We need to be able to support it. Today, liquid cooling is kind of like a snowflake. Each system is very different. What we envision in the future is that it's going to be like standardized, how we are going to measure the temperature, what you're going to do, how much you can cool in the data center, because like you can't even just optimize for one system, you have to optimize for the data center. So there's a thermal limit on how much we can cool, right? All of that has to be optimized. So standardization will help us.
So basically, like in addition to the hardware, you need to have ongoing maintenance, and a lot of work need to be fed from the data center to continue. Go ahead, Adjunct.
Okay, so I think that's a great question, actually. What I want to say is that actually all of us, we cannot do everything by ourselves. So liquid cooling is a kind of a new thing, I think, even though industry uses sometimes long. But as you know, it would be great if expert bring something to the here. And we are currently we are focusing on infrastructure and then data flow framework. So if some expertise brings some specific things to that framework, I think it is a great collaboration between industry and our standards group together.
Good. Thank you. Go ahead, one more question.
The gentleman on the screen, the remote, made an interesting point that the hyperscalers have all the performance telemetry data that even the vendors may not have, because they run all the use cases. Is there a need to define kind of a backwards flow of data from hyperscalers to feed this back to vendors in a kind of neutral, private, secure way?
Yeah, I think I don't know whether you had a chance to join the 230 presentation. He had the flow on both sides. You're not giving one way, it's both way. Panos, you want to add something more?
I think it's for you.
No, I was just going to say that was pretty much the content of the presentation, that we want to establish a standardized and safe flow of the telemetry from the devices, from the components into the appropriate vendors that have the high expertise to analyze that data. And in segue to the previous question, to the sustainability, if we are in a siloed situation that the hyperscaler has to do everything by themselves, it brings a very long-term life cycle to be able to do everything, to validate, optimize, and so on. While if we can offload some of these parts to the experts, then this cycle becomes much shorter, and we are able to try new technologies faster or push the technologies to their limits to extend the lifetime of the components.
Okay, I missed that talk, so.
Good. I think it will be recorded presentation, so it will be available. You can watch. Good. Thank you. Any other
Could I add one more point for that? Actually, as Sammy presented in his keynote today, actually as SCM, we are considering from top-down approach. And until now, as device vendors and we take the bottom-up approach a lot, but actually, as this group will do top-down approach, and also our group we have device vendors and also hyperscaler. So I'm pretty sure we'll meet in the middle very well, and then accommodate it pretty well.
Yes, thank you for reminding. I think at top down we need to emphasize. And we will ask you to, all of you to kind of join the group also, right? So we can all contribute together. Go ahead, your question.
Yeah, so I'm very excited about this whole initiative, Cloud Services Management Initiative. One of the things that I'm struggling with when it comes to cloud, it's not just one type of cloud implementation, right? We have cloud service providers, hyperscalers that own the whole stack, like software service. And then there are cloud service providers where they offer public cloud, like infrastructure as a service. So they may not own the whole host-based infrastructure like kernel and some middlewares. So the solution and the interface and the spec that we are defining, I'm hoping that we are going to develop in a way that it can be applied to these two different type of implementation, and maybe there's some other flavors in between as well. And this is just a kind of a thought process, and I'm open. I mean, I'm interested in hearing your comments about is that something the right approach to define the specs so that it meets multiple different cloud implementations, or are we trying to harmonize the cloud infrastructure stuff, or maybe something on that line?
I'll take a first stab at it. It's a very good question, right? In the case you're asking is that certain times we actually own the whole stack, and certain other things where we actually like operate like a public cloud, we don't control the OS that runs on it, right? And that's like a really like interesting problem. And it's even like there's also even more subset of cases where we actually want to make the whole machine available. That's what is called like bare metal. So we still want all our monitoring and telemetry for the bare metal use case as well, right? And as part of it, we want it to be like flexible. That's what I actually mentioned about the in-band talk that I gave. So we run the management agent in a container. And the key part I mentioned there is that it can be run both either on the host OS as a container, or can actually be run on the hypervisor as well, right? And the third case is that it can be actually a combination of like running on the little bit on the hypervisor and out of band as well, right? So if you want to go fully to the bare metal, like preferred solution would be like totally out of band, but that's actually not always like feasible, right? So even in the hyper fully bare metal case, we run a little bit of a host agent that we run on the host OS. So but that's actually like exactly right? We want to support all the use cases and want to make it like seamless as well, and also like support it across, right? So an agent can actually migrate across as well.
Yeah. By the way, Neil, I think when you asked the question, you kind of thought of the world as two parts, right? One is somebody that's more of a vertical stack that owns everything, like a social media company, like the one you work for, or more of a public cloud, more of a public cloud vendor. But as a silicon vendor supplying to all of you, our common experience has been there is no such thing, because in every company there are properties, and those properties dictate what the special needs are. So there may be one property that dominates and maybe that's how the company is viewed. But if you look at every company, regardless of what it is that you associate with them as a consumer, there are properties where they are uniquely different. So what ends up happening is that you have to support both the dichotomy all the time. There are things that are in band only, and then there are things that are out of band only, and things in between. So even here in CN, this is exactly what I was talking about earlier, right? This is the challenge we have as a silicon vendor. We have to support this superset. And I think now you're seeing that the CSM itself need to support that superset model, because there is no escaping that superset in general, because there is no such thing as a clean, I'm only going to rent VMs and containers, and I'm never going to do bare metal. Because there are enough of those companies that then have to do bare metal. And then even the companies that do bare metal then end up having to have something that they have to do special case for.
Yeah, I agree. In fact, George really touched quite well in terms of developing a framework that can be scaled in band as well as out of band, depending upon the needs. That's pretty very important aspect that we should be looking at. So I'm glad that you guys are thinking about that. Just FYI, within OCP, we have a hardware management sub-project, and within that, there's incubation that myself and a few other people are leading. We call hardware fault management group or subgroup. And we are solving one part of the problem from a bottoms up. So how do you implement a hardware fault management infrastructure bottoms up? So maybe we should collaborate more together.
Yes, definitely.
And any more question? I think I will ask one more closing question.
Thanks.
Yeah.
Thanks for entertaining my question. So, Mohammed from Seagate. I heard a lot about containers, and I apologize if this was discussed earlier on. So, some of your comments about containers kind of made me ask this. So, there's a whole set of innovations that are happening in the Cloud Native Compute Foundation around open telemetry, open census, and all of that. So, are you guys thinking about, because they talk about metrics, tracing, logging, and how to standardize all three of them in a more, open way so that things coming in are all look the same, can be analyzed the same. Can the same framework be applied to a more hardware infrastructure level, or is that a totally different problem space that you guys want to go create your own standard to deal with?
Yeah, good.
Yeah, so I think in some that has to be the goal here. So one of the reasons I think when earlier in the discussion they were mentioning that the vendor, perhaps it was you that mentioned that the vendor, there is always some differentiation in terms of what they end up doing, and this is the problem, right? If there are two vendors, they need to differentiate their products, so they put in something that differentiate them from each other. But if you're a cloud, you don't want any differentiation. You want to see the uniform interface for everything. Here at OCP as CSM, the goal should be to essentially stay ahead in defining enough of this in a standard fashion so the differentiation is elsewhere, not in the things that matter to the cloud as a first order principle, right? That's kind of where the energy of CSM is.
Yeah, I want to add to Mohan's comment, because in the cloud CSM model, we have no control on in some use models, we have no control on the end user workload. But what the commitment we have is the SLAs to make sure the advantages of coming to cloud are still maintained. But at the same time, we have a acceleration of hardware, use models, underlying theme, right? So how do we really fill that gap so that the experience and the end user, the CSMs, can talk the same language when it comes to the lower level stuff? I think that's where the value is for this group.
Hi, Mike Allison from Samsung. One of the issues that I think about in this is I don't understand the rate of change that the hyperscalers are seeing for this common set of data. Because I'm afraid you create a spec and it's out of date a month later because somebody has a new product with a new initiative and we have a new thing to add. Or new technology comes in and it's changing faster than we can figure out how to update a spec over and over and over again to keep up. So have you thought about the scalability with technology changing and this common set of things to be reported and how we're going to deal with that as a whole industry? I mean, how many changes do you see a year? I'm just having a hard time understanding the changes that I see from the development side and the differences I see from the different companies, and what's that going to do from a specmanship point of view?
I can take a stab at it. So there is like a heterogeneity in like hardware, like different accelerator cards, different like I think like liquid cooled systems. So all of them are like the heterogeneity like adds to the complexity, right? But that being said, the problem that we face is not just like one liquid cooled system. We have n liquid cooled systems, right? And it's not like one different new like hardware. It's an equivalent of it by like 3 different vendors or 5 different vendors. That's what is a challenge. What we would try to converge towards is basically kind of like one standard for a one particular type of hardware. There is still going to be heterogeneity. We still have to have standards, but it's also that the standards, as we talked about, like redfish telemetry, would make it actually easy for us, even though it can be different systems, it's structured in a particular way. Or you can actually call about the telemetry model that Panos mentioned. It has an envelope, right? So that you can actually standardize certain parts of it and then customize rest of it, right? So that like the systems that we use to parse this telemetry can also be extensible, right? So if you have like few things that are actually common and standard, you can just plug it into the existing system, and then we can refine the upstream systems as well. So that's what we go for. It will reduce the time to basically enable a new hardware in a data center, and it will also reduce the time for the upstream changes that it's going to consume the data as well.
Yeah, so again, it goes back to the principle of this core group is to standardize, right? So we can have the innovation going through at a lower level, but at the same time, if you really define for scale the interfaces what we are talking about, then it can be easily extended. Today, there's a lot of divergence, and there's an innovation going on underlying, and then especially the CSPs, in order to hold the SLAs and in order to give the most reliable service, they have to keep on modifying the upper stacks to maintain that, right? So the goal of this core group is exactly your point, to really define the architecture in such a way that it is extensible, it is scalable, and for the future needs of the innovation going under the use models, right? So that's exactly the problem that we're trying to tackle. And I mean, this is an open forum. If you have somebody great ideas to how to architect for future, I think we are looking for those voices.
Yeah, Panos, you want to say something? Go ahead.
Yes, I wanted to say that we have tried to design this standard in such a way that it's layered, that you have a very generic outer layer, which is our envelope, and we are able to capture data before some specifics are standardized. Like we install the hardware, we can start from day zero to capture the kind of data it can emit, and then we can transform it later to match some emergent spec and to be able to exploit the data we have captured. So we take it as a fact that things will change all the way. But the point is to be able to have the data in the first place so that we can use it whenever the other systems are ready to consume it.
Okay, thank you. I think we ran over 10 minutes or 15 minutes. Maybe I think the closing question I have for this panel, one question is always burning is what type of additional researches we have to do, and how do we engage more with academia so that that type of research can flourish? You can start, anybody. Yeah.
Yes. So I think one opportunity I see in terms of the CSM use model, mainly the scalability and availability and reliability. Those three vectors, the opportunity is all around predictive analysis. I think the predicting the failure using this mechanism of telemetry data is a most valuable thing at that scale, like millions of server in remote places we are having, and ability to really correct the problem proactively with predictive analysis is a great area to invest in some research. And then the other area I can think of is in this process using this stack, if there are some techniques we can adopt in self-healing kind of technologies at the device level itself or at the upper layer stacks is a great area to research, my opinion.
Yeah, so
Yeah, plus one to what he said, like there's a lot of work that has to go into self-healing, and especially I think like millions of server and where you cannot simply go swap out parts. How do you make the whole system like continue to work in even when there's like partial failure? That's actually like very important. and also able to predict it, right? So if you can predict that something is going to fail, we can move the VMs across. So all of that, like this active, like active research is needed into that.
Yeah, so one of the key problems, since you talked about how do you engage academia and everybody else, one of the problems we have today is that we talked about how cloud has access to a lot of data. Why don't they just put it out? The reason they don't put it out is that it comes from multiple vendors. They can just put it out, and it's also identifying in terms of their infrastructure. I mean, at least I know how many people label their servers. It says, it's in this building, it's in this row, it's in this right? It's extremely identifying to just throw the data out into the world and say, here, go do analysis on it. So one of the things that I see out of this work group is to come up with this abstraction layer that takes that and anonymizes that data to make it possible for you to actually put it out there and not be identifiable to any given vendor or any given premise or any given data center or any of those things. So then you can truly have this model where people are just, doing the analysis on the data and less on trying to indict a specific vendor or a person in the whole process. That I think is the first step, and then everything else the George and Devendra talked about come as a result of that that capability that CSM will produce.
Thank you. Anybody want to add more?
I thought the same things actually. So when I work with academia, one of the big challenges for them is that they cannot find some data. They have some ideas, but they cannot verify if their idea works well or not. So as the previous guy mentioned, actually, if I think if academia research do some anonymized data processing stuff, and also sometimes, as you know, nowadays some technology we could process data even in the compressed ways. So that things would be good research topic, and also the industry for the industry, I think it would be better if we could share more data, even with some anonymized data. That would be much helpful for industry to do a lot of works.
Okay, thank you.
Yes, so just to add, I think this type of work really means it will help drive like reliability and efficiency, because when you stop to think about it, we would be pretty much shortening the gap. So like all that cycle that we find something, interact with the vendor has questions, ask for data, you go provide the data. We would shorten that cycle, like avoid waste of like sending parts around, whereas may not be necessary. And also the academia is a big part where an institution will not have the access for the data. So if researchers are working to do predictive analysis on drive failures, well, they better have lots of drives in order to be able to have a meaningful research. So with this model, we can provide then like do partnerships so that institutions can look at this data, train it. I mean, a lot of the peers run their environments like at different conditions. So one could even see that being temperature-wise, location-wise, like it varies. So the devices would behave different at different places. So I think like having the ability to see all that would be great for the industry as a whole.
Okay, thank you all. It's a good conversation. Thank you for all of you participating. We'll see you in the maybe next CSM session, or join us later. Thank you very much.
Thank you, everyone.